Hello, everyone, and welcome to today's webinar. I'm Rebecca Allen Tapp, Product Manager for Paralab Green. Thank you for joining us. We decided to host this session because of a high volume of inquiries we've received about cryopasteurization, including how it compares to other decontamination methods and some of the common misconceptions. Today, we'll cover how cryopasteurization allows you to achieve reliable microbial reduction while preserving terpenes, cannabinoids, and product quality. We'll dive into science, real-world applications, and EU-GMP compliance considerations. This webinar will be led by Rui Soares, CEO of Paralab, and will be followed by a dedicated Q&A session where Rob Bork from VST will also be present. Feel free to type questions into the chat at any time. We'll address them at the end of the session, and thank you for joining us. Let's get started.
Hello, good morning. My name is Rui Soares. I'm CEO of Paralab. I want to thank you all to be present on this webinar. Today, we will be discussing about Cryo-Pasteurization, what is this technique, and its advantages and benchmarking advantages, science, and also some benchmarking. So we will go first by a very quick introduction to VST, the manufacturer of this technology, then to Paralab Green. We will then start what is bringing us here, the most important part, the scientific and technical background of technology, and we'll discuss also results as well as GACP and GMP compliance, two very important issues. We will briefly go through the different equipment configurations and then a quick benchmark comparison with other decontamination techniques. We will finish with a question and answers session. So, VST. VST is a company that was founded by two brothers, Jim and John Sanfilippo. Sanfilippo is a company that is over close to 4 decades operation, working in the packaging technology, packaging materials, and contamination techniques. They have over 150 patents in this area. VST was a company, the most recent company, founded by John and Jim in this area. VST was founded to work exclusively for the cannabis sector. All the other companies in the past were serving the food, the pharmaceuticals, and medical devices industries. VST is founded in 2020 to serve only the cannabis business in offering technology for contamination, but also for packaging machines as well as packaging materials. The objective is to offer solutions that allow cannabis to be safe for consumption and to have very, very long shelf life, up to 2 years. Paralab Green. As mentioned, I'm CEO. I was also one of the founding member partners of the company. We are in business for 33 years. We are founded in 1992. Of our team, that is composed of over 60 people, of the ones in contact with customers, so sales and after-sales support, of these, 40% have a PhD. Our team has a very, very technical background. We have people coming from all different scientific fields. Initially, we were mainly chemical engineers, but over time, we start hiring chemists, biochemists, physicists, biophysicists, pharmaceutical biologists, as well as mechanical engineers and electronic engineers. We are ISO 9001 certified since 2010. In 2024, we got a EU-GMP license for contract analysis. We have a lab license for human medical products. Since 2025, we have an R&D license for narcotics, in which we use mostly for R&D in cannabis. And also in 2025, very recently, the Portuguese Innovation Agency recognized Paralab as a trusted partner for R&D activities. I mentioned that we are in business for 33 years, since 1992, and since 2018, we entered into the medical cannabis area. Actually, we came because we were already working on extraction and purification for the pharma industry, and it was a natural step that people that were in pharma companies and were moving to cannabis companies started contacting Paralab in extraction initially for the cannabis applications, cannabinoid extraction and purification, but we saw an opportunity also in post-harvest. We were lucky to be one of the first in Europe because Portugal was the first country where medical cannabis was legalized. So we were one of the first in Europe start offering technologies for this industry. And being one of the first, we were able to choose simply the best, most prominent manufacturers of equipment for post-harvest extraction and purification. I can name companies like Mobius, like Paxium, like ATG, like Canatrol, and Vitalis. And of course, VST in contamination, but we also have Green Tech in bioburden control, so of trying to avoid to have flower contaminated, and Medical Genomics, a company in reagents for fast assays, fast analysis of complete range of pathogens present in cannabis. As mentioned, we offer a complete solution. It starts on bioburden control with Green Tech, I mentioned before, so trying to avoid during production in flowering rooms, but as well in all processing in post-harvest and also in extraction to keep the rooms safe with the bioburden control technology that can reduce up to 98% pathogens in the air, on the surfaces, the room walls, ceilings, as well as on the surface of plants. And then post-harvest, bucking, trimming, sorting, drying, the contamination. That's the subject we are here today. And also solutions for packaging, either bulk, either consumer doses, and then extraction from milling to all the relevant extraction solutions for ethanol, for CO2 extraction, solventless, and BHO. Filtration for post-processing, winterization, filtration, vaporization, and decarboxylation. When it comes to purification, we have solutions based on liquid film distillation, in chromatography, and crystallization. Of course, then it's necessary to fill bottles of vapes with these extracts, and we also offer solutions here. Finally, in terms of sanitation, very important, keeping the environments, the rooms, and the equipment properly cleaned and disinfected, solutions based in ultrasonic baths, especially high-capacity ultrasonic baths. And of course, also equipment for analysis of different parameters like cannabinoids, terpenes, load, water activity, for process control as well as quality assurance. But so let's start with the most important part, scientific and technical background. Regarding cryo-pasteurization, as Rebecca mentioned, what triggered this webinar is that we noticed that there were on past month, 6 weeks, several posts, either from competition, well, they were not a post, it was just in their website, some competitors, and posts that people we really admire and have the biggest respect, consultants, very important consultants, very knowledgeable people in this area, that made posts and comments regarding cryo-pasteurization that were technically not correct. Why we think? Because if we were going to AI models like Copilot and Gemini and asked what was cryo-pasteurization, it was said it was a technique that would do the microbial reduction or even sterilization. That is a very strong word, and that's not what we are doing. We are doing microbial or bioburden reduction to desired levels. That this was using liquid nitrogen to eliminate, to kill the pathogens. This is not true. By low temperature, by putting in contact with very, very low temperatures, the pathogens, most of them are actually preserved. They are not eliminated. Cryo-pasteurization, and this is very important, and I hope Copilot Gemini will see the video that will be placed on YouTube. Cryo-pasteurization is not about low temperatures. During the contamination step, is a method that uses heat transfer to heat the flower, the buds, because there is no chance to eliminate pathogens if temperatures are below 70 degrees centigrade, at least for the pathogens that are typically present in cannabis. So if we want to be sure that we are eliminating or we are reducing greatly the content, the concentration of pathogens present in cannabis, we always have to be above temperatures of 70 degrees centigrade. In practice, not to take risks of being on the borderline and so more temperature resistant pathogens not to be really eliminated. Usually no technology using temperature or heat transfer will operate below 75 degrees centigrade. So cryo-pasteurization, it has cryo on name, and we will see why next, but the contamination step is done at temperatures at least above 75 degrees. So who have tried to learn more about cryo-pasteurization and have been in sites like from VST may have heard about cryogenic vapor. What is cryogenic vapor? Cryogenic vapor, it's a mix of an inert gas, nitrogen, argon, for instance, mixed with water vapor. The inert gas, liquid argon or nitrogen, they will be supplied to the machines using this technique in the liquid form. And if we consider, for instance, argon, it has a liquid, his temperature will be minus 186 degrees centigrade, and nitrogen, liquid nitrogen, will have a temperature of minus 196 degrees centigrade. This is why these gases, these liquids, these gases in liquefied gases, they are called cryo gases or cryo nitrogen, cryo argon. And this is where the cryo in the cryo-pasteurization comes, because one of the utilities that is required for this technology is a cryo nitrogen or a cryo argon. And why we are starting with cryo nitrogen or cryo argon? One of the reasons is that we need flows the presence of these gases in very high purity. And if you vaporize cryo nitrogen, for instance, or cryo argon, you will are generating a gas with very high purity. It will always be 99.99, so for nines, but if you take special cares like this does, we will always be above 99.999% purity. This is very important to avoid the presence of oxygen. Oxygen will be in extremely low levels present. Now, so water vapor, inert gas is inert gas will be mixed with water vapor, and this water vapor will be controlled to a desired temperature and a desired saturation level. What we obtain? We obtain an inert atmosphere, very important to avoid oxidation processes, and we will discuss this more in detail during the next slides. We will have in VST studies have been made, and despite above 70, we will have the microbial reduction processes happening. They are faster as temperature is higher, and in terms of maintaining the flower in its original quality, it was found that it's better to work at slightly higher temperatures, but for very short periods, like 2 to 4 minutes maximum, rather than working, let's say, at 75 degrees, but for longer periods. How And why we have these very short periods, 2 to 4 minutes, in using cryopasteurization. Other techniques that use temperature are basically heating the sample by processes that are not so fast. For instance, if we were having nitrogen mixed with water vapor, if it was using, if we were using just nitrogen, and we warming sample by passing a flow of nitrogen at high temperatures. This is basically heat transfer by convection, by a dry gas. This is usually called sensibly heat transfer. This is a very slow process. But we are adding water, and water have here two effects impacting two ways. The first and most important is that we have a vapor. Well, to create the vapor, we had to vaporize the water. And so we have here the heating, the heat of the vaporizing enthalpy of the water. We have to understand that this heat that we need to transfer to the water, to a certain amount of water, to go from the liquid state, let's say at 100 degrees, to the vapor state at 100 degrees. It's a huge amount of water compared to what is necessary to heat water from 0 degrees centigrade to 100 degrees centigrade. For the same amount of water, to vaporize that water when the water is on liquid already at 100, this is 5 times more heat required than one required to heat from 0 to 100 degrees. So this is energy that is stored on vapor. This is latent heat storage in the vapor. When this vapor gets in contact with flour, that it will be at lower temperatures, this water in vapor state will condensate. And this heat, the same amount of heat that it was required to vaporize from liquid to vapor, now when we condensate from vapor to liquid, will be released. Same amount, remember, 5 times more than is required to heat that same amount from 0 to 100 degrees centigrade. So this is a process that happens almost instantly, so it is a very fast heat transfer, but still is controlled. We do not take a risk of getting the solid that where the water is condensating, so our flours, of going over very high temperatures. No, it's always limited for the temperatures that we have in the gas phase. So if, let's say, we are saying that we are using cryopasteurization from 80 to 90 degrees centigrade typically, we are in this case having the gas phase, the mix, the cryogenic vapor, the mix of inert gas and vapor at 80 degrees, independently that having a very fast heat transfer that will warm the sample very fast, it will never go above the 80 degrees centigrade. If this was the temperature that we set the cryo vapor before putting in contact with the sample. So what this will allow us? This will allow us to have a very short period required to warm the sample to desired temperature and to have the bioburden reduction or microbial reduction process happening. Reduction to the levels that we want our final product to have. At the same time, and remember, we are working with a mix of inert gas and water vapor. This is a inert atmosphere. In these conditions, there is no oxidation. Almost all other technologies that we'll be discussing next, because they do not have this inert atmosphere, and most of them even work with oxidative processes. So they are starting, because this way they work, or as an indirect result in other technologies, they are starting oxidative processes, usually lipidic oxidation. And once started, it never stops. Even after packaging material, these oxidation processes continue, and this is what then have an impact on the stability and so on shelf life of the product. With cryopasteurization, we are in conditions that we do not oxidize, actually we stabilize lipids. So we promote stability over shelf life of the product. With VST, it is normal, and we will discuss this more in detail, to have shelf lives up to 2 years. And cryopasteurization in terms of the different steps. So what is happening in equipment on the machine where cryopasteurization is happening? The first step, it will be system stabilization, and first I will go then in more detail next slides on these several steps. The first one, it will be system stabilization for 1 minute. We will have then the period in which the cryo vapor will be being prepared for the next run. At this moment, after it's stable and prepared, the cryo vapor, the operator will receive an indication to load the flour into the machine, and then the bioburden reduction or microbial reduction step will start. This process lasts between 2 to 4 minutes. Next, it comes a very important and unique step, purification. That is basically the longest in this technology. You see that may have around half of the total time, and we will discuss in detail this step, very important. And finally is the unloading of the sample. So in manual mode, in which is only operator, this, each run of cryopasteurization takes between 12 to 16 minutes, typically 14 to, typically 12 to 14 minutes. Is not normal to reach the 15 or 16 minutes, despite in some conditions we may want to set up in that way. This is in manual mode. In automatic mode, and there are configurations for automatic mode, there are some of these steps that are done in parallel, and so it's reduced between 8 to 11 minutes. The first step, the stabilization of the system. Here it's quite simple, because this comes from a previous run. The system has to stabilize in temperature and flows until the control system of the cryopasteurization units do not senses that the temperatures and flows are stable, does not allow the system to move to the next step. That will be cryogenic vapor preparation. So system stabilization typically is 1 minute max, usually even lower, 50 seconds typically. Cryogenic vapor preparation, this is another step that happens quite fast. It's 1 minute, basically, in which we will be mixing water with inert gas and heating both to desired temperature, and also adjusting the water concentration to get the desired saturation level of the vapor. During this process, I will return to the previous step. During this process, the system will be in the chamber where the contamination will happen, and above it, temperatures will increase because we are going to temperatures, as mentioned before, to at least 80 degrees. We do not want to have the flour already near this zone because this will warm the flour without any necessity. So flour will be loaded to the system just after the cryogenic vapor preparation step is finished, and the machine will instruct the operator to load the flour. We say 1 minute, but this can be a fraction of a minute if the operator, knowing how the system works in their timings and is using, that's typical, is already waiting with a box. We call it cassette. It's a box where you can load flour and then finish, and it has a door that in the system will then open. So to load, this can be less than a minute, we say worst case scenario. And once the material is loaded, the equipment will automatically transfer it to the contamination steam treatment chamber. Here, the flour will be having a flow of the cryo vapor flowing through it. This is a small volume. It can hold max 2.5 kilos of flour. The amount of flour that you actually put depends on how dense is the flour, if the buds are more or less dense, if the flours have more or less uniform sizes and shape. All of these will influence on packing density, and because this is a fixed volume, typically you put between 2 kilos to 2.5 kilos. Even if it is very dense, we don't recommend to go over 2.5 kilos. This is the limit that we want a flour in each step inside chamber, at least on current equipment configurations. So this is a small volume. There will be also a small amount of cryovapor that will continuously be flowing during the contamination time that I mentioned before, varies between 2 to 4 minutes. Why 2 or 4 minutes is dependent on the initial contamination level of material. If the material is not that contaminated, so we don't need to make a microbial reduction so strong, we can do just 2 minutes and lower temperatures. If material is highly contaminated, we need more time and higher temperatures. We have controlled volumes and small volumes, and also small amounts of cryovapor. Why? To reduce the chances of terpene levels. If the amount is small in volume, to vaporize terpenes. And if the cryovapor also is small, so the terpenes loss will be very small. Most of the cases you cannot even detect them. Then it comes the longer step, the purification step, 6 to 8 minutes, typically. And in this step, we have several sub-steps. Some will happen in parallel, but the very first one is a step that is happening sequentially and is the first. It's the initial cooling of the product. So, and this is very important compared with other techniques using temperature. Because we have a system that has a flow of gas, we do not have to wait huge amounts of times, at least 20, if not up to 40 minutes for the flour to return to room temperatures from the temperatures over 70 degrees. We have cryo gas, a gas at very low temperatures that can vaporize these liquids, inert liquefied gas to temperatures we desire. So we will vaporize, but to sub-zero temperatures initially. And this will be, in this step, always a flow of the inert gas, no more water vapor present. And this inert gas will start at sub-zero temperatures to pass through the flours, but ramping very quickly to room temperature. This initial part of this ramping takes max 1 minute, but by the very low temperatures that it starts flowing, it will bring the flours to near room temperature in less than 50 seconds. Then 15, then is to wait the remaining periods up to 1 minute to stabilize our flours, because the bigger buds will take a little bit longer to stabilize at room temperature. So after the contamination time, in less than 1 minute, all the flours will be back to room temperature. This is extremely important, and this is why Cryo-Pasteurization have one of several reasons that Cryo-Pasteurization delivers a flour which quality is not affected by the contamination. In parallel, and because we are using an inert gas, we will be flowing away particles that are there. So particles that could come already from dust, dust that come already with flour, but some of the particles may have been generating during the contamination process. We are eliminating, we are killing pathogens. Some of these pathogens, especially mold, not all, but a good portion of the molds and also bacteria, once eliminated, once killed, will become dust that gets free, that's not get stick to the flour. And so by having this flow of nitrogen or argon passing by the flour, we are flowing away all this dust. This has a major impact on the quality of the product after months of packaging. I will discuss this in detail, but it's easy to imagine that if we are packaging flour in which dead mold spores, dead molds present, dead bacteria present, that odor, that smell that you typically have when you open a package with 6-9 months will be much, much lower, if not existence, because it has been flushed away. At the same time, this is happening also in parallel. Remember that we have a technique that has water vapor present, so we will have the flowers increasing slightly in terms of water content, but now this was during the contamination process step, but now with flow of dry inert gas, we are removing any excess water that the flowers may have absorbed. This will allow us to adjust the water content, so the loss and drying, to the desired value. Pharmacopeia nowadays accept 12%. We recommend to adjust to 11.5%, just to be safe, not to be on limits. We notice that many times our customers have flowers quite dry, quite well below the 12%, 9, 10%, so 2 to 3% less than they would be able to sell that flour. Now just imagine this, if you are processing 10 tons per year, I know this is a big number, but then make calculations to your real production, but in 10 tons, if you have a gain of 2 to 3%, let's say 2, even to be pessimistic, if you are just gaining 2% weight, in 10 tons, this is 200 kilos. Now you know the prices that you have on the market and the prices you are selling your flour, 200 kilos per year, a flour extra, that this was water. This represents a huge amount of money, hundreds of thousands of euros. This may even pay by itself this technology. Another point is that when you are delivering the flour at 12%, and usually 12%, around 12% moisture content, this represents in water activity something around 0.6, and it is known that 0.6 is the best water activity for cannabis. At this water activity, the risks of developing microbial contaminations are very low, close to zero, but at this water activity, your flour is not so mechanically fragile, you don't touch and it breaks, so it's mechanically more stable. While packaged, after even months, you will not have buds breaking while in the package, but also doesn't promote oxidative processes of the cannabinoids. So the oxidation of THC, CBD, whatever cannabinoids present in flour to CBN, it's much, much lower, or even in existence during the shelf life of the product. If you have the flour at water activity is close to 0.6, that for most of the cultivars means also the 12% that we buy the Pharmacopeia cannot go over. And finally, the final step, the unloading of the sample. The sample, it will be collected in 1 second cassette, a cassette that will keep the material in acceptable conditions. So when you are removing the cassette, you will not be contaminating again or having risks of contaminating again sample in case of having the room with any contaminated material in airborne conditions. These cassettes will be transferred to the packaging area. Could it be on the same room in a laminar flow cabinet, or ideally in a packaging room? And what are the results that we are getting with this technology? So this technology is, together with the irradiation, the only technology that has the capacity to go to 6 log kill. Actually, at this moment, VIST, as for many lab tests, knows that it can go over 7, 8 log kill. By the way, 6 log kill means 10 to the 6 microbial reduction. So with that reduction of over 1 million times. And maybe in next future, Cryo-Pasteurization will be able commercially to go over 7 or even 8 log kill without less quality damage on flower than other technologies. And I say other technologies, irradiation is the only technology that at this moment can achieve the same level of 6 log kill, so 1 million times reductions. At the same time, is able to meet European Pharmacopeia table 514 that wants the total aerobical microbial counts below 200 counts and the total yeast and mold counts below 20 counts. At the same time, there is not possible to have presence to comply with these requirements, to have the Staphylococcus aureus, the Pseudomonas aeruginosa, and the bill-tolerant negative bacteria present. This is very easy to achieve with Cryo-Pasteurization. And to prove this, so it's lots of parameters, TAMC, TYMC, bill-tolerant gram-negative, Pseudomonas, Aspergillus, all to have a sample that is contaminated in very high levels. In all this is difficult to find on the market. So VIST has been doing these extreme condition tests with inoculated samples. First time I saw this, my first comment was, okay, this is very nice to inoculate samples. Other techniques, I have done this and published nice reports that show very high efficiency, but there is always a drawback in these results that in these tests that are not explained, is that the inoculation has been done by spraying the inoculate, so the contaminant is inoculate full of pathogens at the surface of material by spraying. What happens? You get just a superficial contamination. Superficial contamination for many other techniques is easy to really achieve at least a log kill of free, so to reduce up to 1,000 times. The problem is that surface contamination is not really the reality in cannabis. Many times you have botrytis contamination, bacteria contamination that goes deep into the core of your bud. And this will be very difficult. This is far more difficult to decontaminate than just surface contamination. This is that in all these tests at VIST labs, they always do the inoculation in 2 phases. First, by injecting controlled amounts in the center of the bud to have core contamination of the bud, and then yes, also by having a spray of the buds to get the superficial contamination. And let's consider this extremely contaminated sample with a total aerobical microbial counts of close to 2 million, total yeast and mold counts close to 1 million, the billy tolerant gram negative in the area of 300,000, Pseudomonas, and Pseudomonas are extremely difficult bacteria to have an efficient bioburden reduction because they are highly thermal resistant. And in this case, it was inoculated up to 2 million counts and Aspergillus at 500,000 counts. Using a program at 82 degrees centigrade and 200 seconds, so 3 minutes, 20 seconds, So not even at the limit that VST recommends for cryo-pasteurization, that would have been 4 minutes. So 82 degrees, not maximum temperature, 90 degrees. At 200 seconds, 3 minutes 20, not the max 4 minutes. We are having an almost complete elimination of all pathogens present. Only for the molds, there were still 10 counts, extremely low value, even half of the value admissible in the European Pharmacopeia for table 514 for inhalation products. So the most stringent requirements. If we see here, all parameters were with log kills of 6. These are, so 1 million time reductions required, and technology was very, very efficient. This is what doing the microbiologic tests we found. In the left, we have pre-treatment, on the right, post-treatment. For yeast and mold, for aerobic bacteria, for aspergillus, we see extremely contaminated Petri dishes. Before the treatment, clean, absolutely clean Petri dishes after the treatment with cryo-pasteurization. What can we expect in terms of flour quality using this technology? So this will depend on the initial contamination level. Highly contaminated product will require more stronger the contamination conditions. So higher temperature and longer time. So a highly contaminated material, subject for higher temperatures, subject for higher times, of course, may suffer more than a flour that was less contaminated, and so it was subject to a lower temperature for a shorter period. Is expected on the very high decontamination levels, especially between logs 5 and 1 and 6. So when we are reducing between 100 times to 1 million times the microbial load, is expected that some loss of flour quality may happen. But when we are reducing 1,000 times to 10,000 times, so a log kill of 1 to 4, we have almost no measurable, not detectable flour quality loss. One word on cannabinoids, and I'll go fast. In cannabinoids, you are never affecting cannabinoids. You cannot oxidize cannabinoids in this technology because it's in inert conditions. So oxidation of cannabinoids, CBD, THC, and all minors to CBN simply can't exist. If something is measured, it is well within the error band of the HPLC method of use it for the cannabinoids quantification. When it comes to terpenes, on this, and this applies from log 1 to log 6, cannabinoids are never affected. Coming to terpenes, and because they are more volatile and we have temperature, let's analyze what is happening. For logs 1 to 4, so from 1,000 to 10,000, we can't measure losses. Basically, if they are measured very small, we will see something next, like 1%, but it's basically negligible. When I say 1%, is 1% of the total terpenes. When we go from 10,000 to 100,000, we may see some degradation, something on the order of 1-2%. When we go to logs of 5 to 6, so between 100,000 to 1 million, we could see some higher, but still very controlled limits. Usually depends on the cultivar, depends on the morphology of sample, and also on terpenes present, because ones are more volatile than the others. You may lose 5% of the total terpenes. Still very low, still lower than, I think, all other technologies. In terms of color, up to 100,000, we don't have any meaningful color change. Between 5 to 6 and above 6, there are tests going on, you may see a slightly change of the chromatic profile. So the greens will get slightly darker green, the purples will get slightly darker purple, but this is nothing compared with the only other technology, that is irradiation, the other technology that can come to these very high decontamination levels that will deliver a brown burned sample. Cryo-pasteurization will have a much smaller impact in the color of the flower. In terms of density of the bud, up to 100,000, it's from non-detectable to very small. We may have still negligible, but starting to be a little bit more noticeable. Let's say if you are in 6, at 5, not so much. In 6, you may see something, but again, the only other technology that can get here, irradiation, will have even a most stronger impact. At least these are the comments of customers that move it from irradiation to cryo-pasteurization. They say that when operating in very high kill rates, so 5, 6, that the flower is much less affected than irradiation. We have here an example. We are subjecting the material, the flower, to the most common program, a program that runs at 81 degrees for 2 minutes. This is a program that can have a microbial reduction up to 4 log, typically 3 log for bacteria, 4 log for yeast, and the effect in terpenes we are seeing here that is quite low. So in terms of terpenes, the samples before the analysis have 2.324% of terpenes. After the cryo-pasteurization process, they have 2.282. We can see a loss of 0.042 absolute percent, but when we go and see, okay, percentually on the initial terpenes, not absolute, was this amount represents, it represents just 1.8%. So this, if you are in your label for this material, if you are putting at 1 digit, they are both 2.3%. These are meaningful losses, even within the error or very close to the error band on terpenes analysis by gas chromatography with that space analysis. In the cannabinoids, I mentioned before that by the conditions that is operated, that is impossible to lose cannabinoids, THC, CBD, is not lose, they will be converted in another cannabinoid, CBN, is virtually impossible. And we can measure these, and we are seeing this even more. Cannabinoids analysis using HPLC, and this is the reference method of, they do not have a very high repeatability. If you send the same sample to different labs, you may have variations that from the real value will be even over the admissible 10%. Even inside the same lab, you can have those chances, those variations, and this is a good example. We are measuring more cannabinoids after the VST process than before, but it will be nice, but cryo-pasteurization cannot create cannabinoids. Here, this is just the typical errors that we are getting in the cannabinoids profile analysis, but this is something that every lab lives. We know that these variations happens. In this case, it was a variation of a gain of 3.6% of cannabinoids. This does have no mean. We will be on the same levels, of course, if there was not these analytical errors that are extremely common. Color change, we are seeing here also no color change. One thing you may even notice here in these two pictures, and I brought this on purpose, you may notice that, oh, it looks like post-treatment is slightly darker. This has to be, remember, this comes from 2.5 kilos, and we have here just a few, less even maybe than 100 grams, like 100 grams of flowers max. And you will see that on the left, before this, there are even darker flowers than on the right. This has to be with samples that have been sample aleatory, and depends, even some buds in one side will be very clear, on the other side will be slightly more purple. This is not even red, this is some purple zones. We could have chosen a better picture, but I have to say I chose these pictures because they had better resolution than others that I had to choose from, in which there will be no dots on color change. Coming to microbiology load, microbiology load. Now, if we go in detail with microscopy, not microbiology, microscopy analysis, we see before and after, and even after we can see the trichomes extremely well defined. This doesn't have, even at the microscopic level, major impact. Difficult to find. You may find something, but again, it's very high. The contamination levels on 5-6 log contamination, 100,000, 1 million times. It's typical to happen. GMP compliance. So GACP, GMP compliance. Let's talk about GACP, because to be in a GMP process, first you have to have produced the flower in GACP, and even in some cases have to process it part in post-harvest, part as a GACP process, although you can start immediately being a GMP process on post-harvest. And the European Medicines Agency, that is the agency issuing the GACP and GMP guidelines, they had a revision this year in 12 August of 2025, in which they included steam, and steam is water vapor, as one of the accepted technologies for bioburden reduction, for decontamination. Of course, that also this guideline informs that companies should not be decontaminating, so doing a remediation of the flower as the standard procedure. This should be done only if the flower is contaminated, and they should take all cares required and possible to reduce the amount of the microbial load, bioburden load, during the producing process, during the agriculture step, during the production of the cannabis flower. Also, and considering that it goes later to a GMP process, but even if it's, and attention, companies that are not GMP certified still can run Cryo-Pasteurization as a GACP process. Nevertheless, it's always very important to document temperature, pressure, and exposure time of this technology. And in terms of EU-GMP compliance, one very important is the process performance and the validation of this process. And to validate a process, you can only validate a process is if the technology that is being validated has consistent results. So if when you using the same material, get always the desired final result consistently, run after run, batch after a batch. And Cryo-Pasteurization, it's extremely reliable. It comes also to software that is GACP 5 compatible. It has been developed by GACP 5 guidelines. It has user access level control. It has audit trail log. All digital records are warm. Warm means write once, read many. And data integrity is also there. So once written, you can change any of these digital records. Another very important issue for GMP processes is to avoid cross-contamination between batches. This is assured by correct SOPs for cleaning, but the system has also built-in sterilization in place, so SIP technologies. After cleaning, let's say in middle of the day, if you are changing a batch in middle of the day, you do a cleaning, and then you will do a sterilization of the machine, basically running in blank, no product, no flour. We'll do a sterilization step that warms all parts in contact with product, with flour. All parts will be warmed to 94, 95 degrees centigrade for a certain period of time. This is built-in technology in every cryo-pasteurization machine of VST. And finally, to have full EU-GMP compliance, the complete documentation package. If the customer URS requires any changes or updates to the machine, VST will create DQ documentation that will then be approved by the customer before those changes are implemented. By standard, all IQ documents are supplied. The certificates for weighted materials are supplied. Diagrams, either for mechanical or for electrical parts, are supplied. User manuals, SOPs for cleaning, SOPs for operation, SOPs for safety, and also for maintenance are supplied. The factory acceptance tests, as well as site acceptance tests. And Paralab and VST support their customers in developing the process qualification documentation tool, for which we have a template, but it has always had to be adapted to small details that each company, different details that each company will have in their process validation. And the performance qualification has to be in accordance with the process validation developed by each company. Process validation remember, this is something that is responsibility of the customer with the support of the manufacturer and distributors like Paralab. At this moment, we have one instrument installed in a facility in Europe, one in Portugal. They already have the audit. It went very well. They are waiting at any moment to receive the license to update cryo-pasteurization in their quality system. There are 5 more systems in Europe in installation or in way to the customer or in production. And not only in Europe, but also in other parts of the world, like Canada and in Colombia, where there are units operating or about to operate in EU-GMP facilities, and many units operating between Canada, United States, and Latin America in GACP facilities, already in some cases, for more than 2 years. Equipment configurations. The base unit, the VST-25, it's a unit that when operated in manual mode and in standalone unit, as you see here, can only operate in standalone mode, will have a throughput up to 11 kilograms. Although this means operating in parallel mode, in some of those steps mentioned before will be done in parallel. We don't recommend that in manual mode you do this. It's too much things for an operator to take attention, and then it cannot comply. So the best is to use parallel mode just with automation that we see next slides. And so in manual mode, typically you do not have 11 kilos per hour. You will have 8 to 10 kilos per hour. These 8 to 10 kilos are depending only on the density, packing density of your flour, since we have this limited volume. This technology, since we have a liquid, a cryogenic liquid, we can use it to do, this is nothing to do with contamination, this is a bonus who have this technology. They can do flash freezing of flours. This is good for companies that also have extraction methods like BHO, like ethanol extraction, and also solvent extraction, because these 3 extraction techniques, they absolutely need, like BHO and solventless, or it's good too, in case of ethanol, to supply frozen material at the extractor. There is also an option for terpene infusions, so to increase or change the terpene profile of flowers. But attention, this is not for medical applications because it's not admissible for a flower that is considered an API to have added components. This is formulation, and flower is an API, not a formulated product. So not acceptable to do this in medical cannabis applications. Now, this machine can be upgraded with a high output model. With this model, you will have some of the steps of the cryo-pasteurization process being done in parallel, and it will increase up to 80 kilograms per hour the throughput of the cryo-pasteurization. We see here two conveyors, one conveyor on the left feeding the flower automatically to the machine, and another conveyor transferring flower out of the machine. This conveyor, the outfeed conveyor, is under pressure of the inert gas, so maintaining aseptic conditions in the transfer. This is transferred usually for a packaging machine from VST that we will see next, or to a laminar flow cabinet where you are in the same room of the contamination room packaging your flower, or to a packaging room nearby. Talking about the packaging machines of VST, the VST AMAPS VF30, and AMAPS means Aseptic Modified Atmosphere Packaging System. So it's a technology developed by VST that allows the materials inside the package to be in an atmosphere with very low oxygen level, max 1000 ppm, not the traditional 1-2%. This is below 0.1%, below 1000 ppm. Typical sizes are 0.5 kilograms, 2.5 kilograms, and 5 kilograms, but other sizes like 1 kilogram are also possible. With this combination of the VST contamination technology with the VST packaging technology that has the very low, that generates packages with extremely low levels of oxygen, also with the VST packaging materials that have ultra high barrier. So ultra high barrier to prevent migration of oxygen to the package, water vapor to the package. The shelf lives of flower decontaminated by cryo-pasteurization and packaged by the VST technology with the VST packaging materials will have stabilities up to 2 years, stability, shelf life stability up to 2 years. Is this important? It depends. A few years ago, people were having, where demand was not so high as production, the offer. Many companies had flour getting well over shelf life, and would have loved it to have materials with a shelf life above 1 year. Remember that Germany may be changing laws, restricting the prescription or making it more difficult to access the prescription. Maybe the market will decrease, and maybe the producers will be again in a situation that would like to have a shelf life stability above 1 year. VST delivers this. But in regular conditions, and we hope that this doesn't happen, or market recovers very fast, and it will, with, for instance, the France coming now into the market with legalization of cannabis. So the market will have another boost from France that may compensate temporary loss of market in Germany if worse happens. But even in these normal conditions that you do not care to have stabilities over 1 year, the point is that if you have 2 years stability, it happens because the product is far more stable, degrades at a much lower speed. What happens when you open a package of flour decontaminated with cryo-pasteurization and packaged with this technology? The experience of smelling, let's say, a package with 9 months will be even superior in terms of odor of a package than with other decontamination technique and other packaging techniques with just 3 months. After 3 months, you're still smelling, feeling some moldy flavor and loss of the beans. With a VST with 9 months, 1 year, you will have an experience that looks of something that is probably 1-2 months with other technologies. This is unique. The perception of quality of a user when opens a package of processed with VST is far superior with any other technology. Now, we can increase the throughput. So if we had the VST, the VST decontamination with the AMAPS VF30 machine, in which is the same 18 kilograms per hour, but now we are not only contaminating, we are in real time also packaging under very inert conditions, keeping oxygen below 1000 ppms. I did not mention before, but each AMAPS VF30, so the packaging machine, can decontaminate, can process 2 decontamination machines at the same time. So if you add a second machine together with 2 high output models and 1 packaging AMAPS VF30, you will be able to decontaminate up to 36 kilos per hour and also packaging those 36 kilos per hour. Now, if you double this arrangement, you can go to an insanely ultra high throughput of 72 kilograms per hour. For medical cannabis, this is huge. Even for recreational, this would be very, very high numbers. We show this combination because if someone goes to this, if one day a company in Europe will be here, when selling such a combination, of course, that price is different of just the sum of the individual prices of all. There will be discounts applied for these configurations. Comparisons with other techniques. And we have first to understand that there are 3 major processes for the contamination, for microbial reduction. First, using irradiation. Irradiation are technologies based in ionizing radiations. So irradiations like gamma, E-beam, and X-ray. Gamma and E-beam, they are usually for high throughputs, usually for facilities that offer irradiation as a service. X-ray is more common for in-house decontamination. Then we have another group of technologies based on oxidative atmospheres. Basically, we will subject our material to very oxidizing atmospheres like ozone, like hydrogen peroxide, or cold plasma. And the oxidative atmospheres will eliminate the pathogens. Finally, there are techniques based in temperature, like microwave, like radio frequency, but also water steam and cryo-pasteurization. Let's analyze the plus and minus of each of these technologies. Irradiation using gamma, X-beam, or X-ray, this is more or less same to all. Gamma, by having more energy at each moment, is faster than E-beam, and E-beam is faster than X-ray. Gamma and E-beam is in minutes, X-ray will be in hours. Something between, manufacturers say, between 6 to 10 hours, my experience between 8 to 10 hours. Or let's say the 10 hours is, and plus, attention, many times plus 2 hours in X-ray to let the X-ray source to cool. So you can do in X-ray just 2 runs per day in 24 hours, and you need someone in facility for a second shift just to unload, wait, and load sample for the next one, 24 hours if you want to run twice. This technique used to be the reference technique, and I used to sell, Paralab used to sell irradiation systems based on X-ray, and they were de facto the reference technique in the past. It can do up to 6 log kill, so to reduce microbial load up to 1 million times, and can also get product that is in accordance to Pharmacopeia Table 514 for inhalation products, most stringent low limits. But in minus, what happens? This was nothing to do with technology, just some legal issues, law issues in the German market that require that product that is irradiated to be labeled as irradiated, and the market got a bad perception of this labeling. Basically, customers avoid buying products that are labeled as irradiated. So the operators in this market usually do not want to buy at all product that has been irradiated, or will require producers to sell it at an extremely low price. Another point is that when it goes to 5-6 log, the flower is highly affected. Color is one of the parameters, but terpenes too. Then we have the contamination techniques based on oxidative atmospheres. In terms of advantages, plus points, only one: low cost. There is no other advantage to use this technology. Compared with all the others, the initial investment is lower. However, it's limited to a max of a log kill of 3, so no more than 1,000 times reduction. And even so, to get to these high log kills, the flower is extremely effective because it's necessary to have high concentration of all those oxidative reagents and for longer times. Also, it has been a problem to do the process validation. I know of 2 cases in Portugal that failed. I know 1 case in Switzerland that failed. Also, this customer in Switzerland was considering Cryo-Pasteurization. By the highest investment, decided to go 2 years ago on a cold plasma machine, but after 1 year and a half, came back and bought a Cryo-Pasteurization unit because he was not able to validate the process. And without validation, you cannot operate it in a GMP facility. Now, on temperature, and let's consider technologies that use radiation. Remember, it's not radiation, but from the electromagnetic spectrum. It's nothing to do with the ionizing radiations that are also in electromagnetic, but are ionizing. These 2 radiations, microwave and radio frequency, they are not ionizing radiation. They also do not use chemicals like oxidative technologies. This is 2 very strong plus, but they are typically limited to a max of 3. Some manufacturers are pushing to 4, but I think this is just because there are competition above 3. They want to push here, but even a 3, it is known to affect somehow the flower. At 4 affects far more. And why? Because the time that these technologies require to be at high temperature are very long. Temperature speaking, they will be on same range of steam that we'll see next and Cryo-Pasteurization, but the times that are during the contamination time are higher, 14 to 20 minutes. And then because this is done many times already packaged and in closed volumes in which there is no flow of inert gases, this will have also a long time to go from those 70 many to 80 up to 90, or even I heard 95 for these technologies, to decrease down to room temperature at least 20 minutes, but also in some cases up to 40 minutes. It's a long time between 40 and 20 minutes of the contamination step and then the cool down to room temperature. Water steam, so basically is water vapor, pure water vapor under vacuum. You know that water boils at 100 degrees at ambient pressure, but may boil at 70 degrees at vacuum levels or absolute pressures of around, I think I may be wrong, but it's on the zone of 20 millibar. So if you want 70 degrees and vapor pressure present, you will decrease the vacuum to these around 20 millibar. Pardon me if it is not the right value, but by memory, I would say that 70 degrees will be on the 20 millibar, so that if you give heat, transfer heat to the system, the water will vaporize and will stabilize around 70 degrees. If you want higher temperature, then yes, the vacuum level will not be so low, it will be slightly higher, but we are always talking a quite demanding vacuum levels. If you have vacuum and you have high temperature, you are promoting the loss of terpenes. This is one of the disadvantages of this technique. And if we compare with cryo-pasteurization, and we saw cryo-pasteurization have an heating time of 2 to 4 minutes for the contamination, and cools to room temperature in 15 seconds, max 1 minute for very large birds, to the core of very large birds. This technology still have 10 to 14 minutes times of contamination, so high temperatures, and it will be probably over 20 minutes to cool down to the room temperature. So cryo-pasteurization, it's a technology that is gentle and natural process. It does not have harmful chemicals. It has very short decontamination times and cooling times, so subjecting the flour to high temperatures for a very short period, and this prevents the flour to lose quality, to be affected. It maintains entirely the cannabinoid level. It preserves terpenes. Terpenes loss is negligible or minimal. Preserves color in most conditions. Never allow flour to burn, as well as bud density. All of these, together with the VST packaging technology, will allow you to have this up to 2 years life shelf stability. And at any moment when you open a package with these technologies, to have always a much stronger and nice odor than any other technology. As a business, and because we are all, I'm speaking to operators, people that sells flour for their companies, gives much higher security for the investment. It's more, it has a higher efficacy. We can go to 6 log at least and still maintaining table 514 for the inhalation products, and it will increase to 7, 8. So it will be very, very high. It will be even higher in terms of the contamination capacities, and it's already 6 and it will be above 6. Also achieves the 5.14 inhalation products limits, and it's pasteurization. We know that in food, in pharma, in dietetical products, nutraceutical products, cryo-pasteurization, it's the technique, the first choice for the contamination. Cryo-pasteurization is started to be in beginning an option to irradiation, but sincerely, for all we have been seeing, this is de facto the new standard in flour decontamination. This doesn't replace, this is not an option to irradiation. This is the state of the art in bioburden reduction, microbial reduction. It's done. That's what I would like to have present today. I'm sorry I extended in almost 15 minutes my presentation, but there was a lot of information that I considered to be important to pass to you. So I'm now open to questions. We may have also Rob Burke from VST present if anyone has questions and would like to be have those doubts, questions cleared.
Thanks so much, Rui. Actually, we did get quite a few questions during the presentation, which Rob was able to answer in the chat, but I thought it might be good to kind of go back and touch on a few of those questions. So I'll go ahead and pitch those over to you and Rob, and you could decide who would like to answer them.
So the first question we got was from James on how the endpoint is determined.
Rob, you want to reply to that one?
Yeah, so I just answered in the chat that it really does depend on the initial bioburden. So we do recommend testing the product before processing. Over time, as you develop internal data on the typical bioburden, those testing pre-processing can be reduced to fewer levels with internal QA guidelines. This does, and many of our clients use, this does provide pre-made microbial petrofilm test kits that are results in about 24 to 48 hours. You can have an initial read, usually if something's very contaminated, very quickly in 24 hours, and then official results after 48. Just with in-house technicians in typically a laminar flow hood or some sort of clean room, and just with an incubator as equipment. It's very easy to do.
Okay, I may add that in a GMP environment, you will have to go through the process validation. And so in process validation, you will test products with different initial contaminations and also different types of contaminations. It's necessary to understand that some bacteria are more heat resistant than others. So based on the findings, results that you have, that you get during the process validation phase, you will define criteria that flour that fits into these criteria will be processed using this program. Flights that fits on a second group will have another program to be processed, and so on and so on. This can be one single variable like the contamination, initial contamination level, but can go to other variables. I wouldn't like to discuss this because this is giving too much information. This is information for customers. This is important information that we know that some competitive technologies have problems with that. I don't want to give them a solution. It's just for VST and VST customers to discuss in detail this info and after NDA signing.
Thank you, Rui. James, I see that you asked a follow-up question. As Rui mentioned, I think this would be something that we speak with you directly on. So feel free to message me your email address if we don't already have it, and we can continue this conversation. So I'll go on to the next one, which was from Dirk. And it's, is there a pressure difference, positive or negative, or is the system running at atmospheric pressure?
So yeah. It's running at atmospheric pressure. We don't pull a vacuum. We're just pushing that inert atmosphere with the water vapor into the chamber.
Yes, atmospheric pressure.
Yeah.
Perfect. And then we had another one from James right after that says, do you require microbial level testing in advance of use?
Could you please repeat the last part?
Yes. So I think he's essentially asking do you need to do microbial level testing before using the material?
No, absolutely. You need to understand what is the initial. It's like this. If you want, I mentioned that the program that will be used, temperature and time of contamination, depends among other variables, but most important is the initial contamination level. So if you don't want to subject your flour to unnecessary hard conditions, so higher temperature, longer time, if your material has low contamination, so you need to measure, you need to understand what is the initial contamination level so that you use the program that gives the conditions required to bring the product to the desired final levels in terms of microbial load, and no more. If someone says, well, I don't want to have this problem, you can work with the hardest program like I showed before that can have the 6 log, the 6 kilo capability, so to reduce 1 million times. But this program will have some impact on the quality of flour. Why to subject the flour to these conditions? If eventually a program that it's operating at a lower temperature, like 5 degrees less, at 4 times less, half the time, so in spite of 4 minutes, 2 minutes, quite subject, because these other programs will have basically zero impact on our flour quality. So the reply is, it's strongly advised. If you are operating in a GMP environment, you have to do process control. You have to have the capability to measure.
Okay. So after that, we have a question from Alexander. Oh, did you have anything to add to that, Rob? Did I cut you off?
Nope, all good. Sorry, I'm answering Enrique in chat just real quick.
Okay, I couldn't tell at the face. I was like, I don't want to jump in there. Okay, so Alexander asked, do you have historical data on cannabinoids and terpenes after cryopasteurization is used compared to non-decontaminated flour? And is there statistically significant difference in terpenes and cannabinoid content?
Well, I showed some of this info. In cannabinoids, there is extensive information because you always measure. Terpenes, there is less at this moment because, as you know, since beginning of 2024, with the revision of Pharmacopeia, European Pharmacopeia, terpenes were removed from the requirement of being measured. So many companies do not measure. So when we are customers, this info is not there. So there is not so much historical data, is less available, but all the data that is available show that the influence is small, like measured there, and especially when we are dealing with experienced growers. Many times they don't need the COA. They just by smelling the non-treated flour and treated flour, they can see immediately the differences. And the funny part is that at up to 10,000, many times up to 1,000 microbial reduction, so up to always up to 4 log and sometimes to 5 kilolog, it's difficult people cannot see the difference. If the programs are run, and attention is not only contamination time, the purification process is also critical. We cannot abuse of that process, otherwise, yes, you may lose some terpenes. Now, in cannabinoids, you can't lose cannabinoids with this technology. It's impossible. There are no conditions to have cannabinoids loss, even to be able to sense, to actually measure, for instance, decarboxylation of DHCA into delta 9 THC. It's impossible. So the reply is yes, lots of cannabinoid info and some information in terpenes and growing. Every time that is measured, the results show. What I showed before, like we were losing 2% of total terpenes. So in that case, losing 2% of terpenes, the flour was still 2.3% before and after. If we go to the higher kilogs, this will go to 5%. So 5% will be, say, in a flour that is 2%, to be 2 or 2.1, to be 3 or to be 3.2%. Is this critical? I don't think so. Personally, I don't think so. The effects on terpenes is small, and as mentioned before, the step that could create problems here on terpenes, it's just during the contamination that we have higher temperatures, but this is done by a very short time and with a very small amount of cryovapor present. So if you not have a big volume, a big amount of cryovapor, there is not so much transfer, vaporization of terpenes to the cryovapor. And so you are restraining, you are controlling the terpenes loss this way.
Okay, thank you. Dirk asked if reverse osmosis or RO water is required or just filtered water.
Reverse osmosis water is necessary. Reverse osmosis plus the filtering with 0.2 microns, or even imagine the consumption of water is very, very small. We are talking about just a few liters per day if the machine runs continuously. If you have a laboratory of microbiology, most probably you have an ultra pure water machine that gives you several liters, up to 10 liters per hour. You can use the ultra pure water from your lab equipment. This is water even with higher specs than required. But if you have a lab equipment for this, don't go invest in a reverse osmosis just for this unless you already have it by any other process on your plant. And to mention, these investments, if it is by a lab machine, they vary between 3,000 to 6,000 euros in a machine to produce water, depending on the model and the brand.
Okay, thank you. Paulina wants to know, is there an initial maximum bioburden level above which the process will no longer be efficient?
I think that VST is testing limits, and they didn't find the limits yet. It's always increasing, but Rob is the right person. He's the one running the tests.
Yeah, so as Rory mentioned, we've started to do our artificial inoculation runs, and we're trying to maximize every time just how many CFU we can add onto the product. And tests have been great. We've done up to 20 million so far, I've seen, on product that we've inoculated in house, and we've been able to take those to zeros. Obviously, as we explained during the webinar, when you are dealing with something with very, very high contamination levels, we do see some drop off in terpenes, but it is definitely better than any of the other options I've seen out there.
Awesome. Great, thanks. This next one is one I can answer. So Leopoldo wanted to know if it is possible to rewatch this webinar. And yes, all registered attendees will be sent a recorded version of the webinar to rewatch. We don't expect you to have retained all of the information in this webinar, so that will be in your email inbox shortly. And then after that, we had one from Henrique, which is a long one. It says, hi, it was stated that vacuum volatilizes terpenes. Why is that? I understand temperature is more important on volatilization of aromatic compounds. Couldn't vacuum help in decreasing temperatures on the decontamination cycle, thus improving the end result? Also, what is the point of having the open hopper coming out of the decontamination machine into the packaging machine and having the product exposed to oxidative contaminated environment on that hopper?
Well, it's a long question. First, yep.
I answered it in the chat. So vacuum can pull out any of the volatile terpenes that are in the product headspace. We have found that it's much better to rapidly cool the product after pasteurization with that nitrogen in order to condense any volatiles that are there in the headspace. It causes a much less drop in terpenes than any vacuum systems we've tested or seen out in the market. There are some of the other technologies that do pull a vacuum, and I've seen a much greater terpene loss in all of those systems. And for the transfer out of the cryopasteurization into the packaging system, all of those hoppers that you see in the pictures that we were sharing, all the ones leaving the cryopasterizer and transferring into the modified atmosphere packaging systems are covered hoppers that are gas flushed with modified atmosphere as well to protect the product integrity.
I would add something. So just finishing on this, the only hopper in which the product is exposed, it's in air, is the in-feed hopper, the larger one on left. And then, as Rob said, yes, all the others, they are under an inert gas aseptic conditions. So the transfer, it comes in unaccepted conditions for the machine and is maintained in accepted conditions till delivered to a place in which there are no risks of contaminations. Regarding the vacuum, it's like this. In the case of steam, okay, so we are talking about steam. So you just have water and you put it and you create a vacuum and you actually control the temperature that the chamber will stay by the vacuum level. The point is that when you do vacuum, you decrease the boiling point, but still you have boiling. When you have boiling, you have material vaporizing. Take the example of water. Water at ambient pressure has a boiling point of 100 degrees. But if you decrease the pressure, so if you put water under vacuum, the water will volatilize, will vaporize at a lower temperature. The same applies to terpenes. You are decreasing the temperature of the chamber so that the temperature of the vapor of the water is controlled by the vacuum level, and you have there your terpenes that, in spite of being at atmospheric pressure, they are now at vacuum. What happens? First, you can't go below 70 degrees centigrade because it's not a question of pressure and the temperature. If that temperature and that pressure promote more or less vaporization, you have to be above 70 degrees. Otherwise, there are pathogens in cannabis that simply resist. You can be hours and they are still alive. They are not eliminated, okay? So you always have to be above 70, and typically everyone is operating above 75. But even imagine that steam works at 70 degrees, okay? To work at 70 degrees, the pressure has to be even lower. And every time, and this is thermodynamics, physics, when you decrease the pressure in a closed volume and you have a liquid there, you are decreasing its boiling point. So the material will start evaporating much sooner at lower temperatures. So actually, by operating under vacuum, and you are operating under vacuum so that you have an atmosphere of just water vapor below 100 degrees, because you could not have water vapor only at 100, well, it will be then water vapor only at atmospheric pressure will be 100 degrees, and then we'll be totally cooking the flour. We don't want that. So to bring this water vapor temperature below, into gas phase as a vapor, below 100 degrees, we have to put vacuum. And by that, we are promoting the evaporation of the terpenes. As water evaporates more easily, at lower temperatures, also will happen to terpenes. That's no mistakes there. If you want to lose less terpenes by operating at atmospheric pressure, you are losing less terpenes. This is very easy physics.
Thank you so much. So the last two questions that I have, we've already had Rob gone in and answered them directly, but just in case there's anything else we want to add. The first one was Neil asked how much nitrogen is used in the process and is it costly?
In terms of cost, around Europe, it's in average, it's easier in Portugal, and I've realized in other countries that typically is 2 euros per kilo, knowing that 1 kilo is 1 point something liters, not much, but around that. And in terms of the amount, let's say a dewar that has 230 liters is able to run, Rob, correct me, 50 runs, correct?
Yeah, it does roughly about 100 kilograms, or yeah.
100 kilograms or 100 kilograms of flour. These are 50 cycles. So we are using between 4 to 5 liters of nitrogen per run. That is slightly less than the 4 or 5 kilos. Which the cost of per run will be on the range of the 8 euros. The 8 euros will process 2 kilos to 2.5 kilos of flour.
Yeah. Many of our clients operate with those 230 liter dewars that you mentioned. They're widely available by Praxair, Lindy. We do have some clients that have gotten their own microbulk tanks installed at their facility. When they do that, the price can drop significantly.
This is when you buy one dewar. Yes, this is the price for one dewar. Only if you run the machine continuously and you have a central tank, then the cost reduces significantly. I'm giving worst case scenario. You just have one dewar that you may replace every month or every few weeks, whatever. Higher consumption of nitrogen will bring price down.
Great, thanks. I wrote that down for myself for future conversations as well, so I'm learning too. Leopoldo asked, how easy is the cleaning process between batches, and does it require a disassembly?
And so I answered in chat that it's a two-step clean in place process. There's a brush down, blow down, and then a cleaning with steam and surfactant. And then once that's been done by the technician, it takes about 20 minutes. The system has a self-sterilization process that heats all surfaces to 200 Fahrenheit. I'm not sure, Rui, what that is in Celsius.
It will be on the 90 many.
I think it's 95, maybe.
95 degrees, yes.
Yeah. And it holds that for several
minutes. The sterilization is done at 95 degrees centigrade. Yes. All metal parts in contact, all parts in contact with product, they are heated to 95 degrees. So at these temperatures, you have maturation and any protein. No organism may survive to this temperature.
Yeah. And then I did answer, some parts can be disassembled for a thorough semi-annual clean. The doors underneath the product can be taken out, but they're all designed with quick disconnect fittings to be taken out to sonication or a washing station.
Yes, the one remark, every day you do the 20 minutes cleaning that Rob said, it's when you change batches. That is recommended to do this disassembling of the doors and cleaning of the doors. This will add 1 hour max, correct? And 1 hour max is plenty of time to do this, to do a thorough cleaning. This is to avoid, it's not a question of microbiological contamination. This is not to take any risk of leaving cross-contamination of a particle of dust or whatever that is required to take these doors out and to do cleaning. This is every batch, not every day.
And this is something that is part of these, the extra added value of working with Paralab and having us do this is that we go on site and we train on how to do this. We write documents on, recommended cleaning procedures and things like that. So this will be something that if you purchase a unit from us, your team will be educated on how to do this and trained so that you understand the process and can do it and develop SOPs on it for your own in-house use. So that concludes all the questions that I have that I've seen from the chat. So if there are any last minute ones, I guess they could get in right now. Otherwise, we're at a good point to wrap it up.
Thank you for everything, Rui and Rebecca. And Rebecca, you just touched on a point that I think is very important. VIST strongly believes in supporting our customers, supporting our machines. And that's been a part of our vision from the beginning. We support all our customers. We're very thorough, in-depth, especially along with, as Rui was talking, custom design qualifications. We've been through the process many times, and that's part of why we chose Paralab Green to work with. We love their team; they're very thorough, and they have the same vision as us, supporting their clients in the machines they put out there in the market.
Thank you, Rob.
Yeah, we really appreciate it, and look forward to answering more questions offline from customers as they come in. Anyone feel free to direct message me your contact information if you want me to follow up immediately. Otherwise, this webinar will be sent to all registered attendees. So thank you, Rob and Rui, for being here today, and to the awesome Paralab marketing team for putting this together for us.
And thank you to everyone that accepted the invitation and took the time to be here today. I hope to have a chance to meet all of you one day. Next stop is next week in MJBizCon. Maybe someone will visit. So if you are visiting MJBizCon, please stop by VST booth or Eterus Mobius booth. I will be between these booths and be very glad to speak with you. Just one more notice, because for Latin America, and Latin Americans in general, but Latin America in particular, because Paralab is very active in Latin America, this is not the best timing, too early. We have some people from Latin America present. If you know colleagues that didn't attend because of very early time, we will be announcing very soon that on the 9th of January, there will be a second edition of this same webinar at a schedule that makes more sense to Americas. So it will be an opportunity for your colleagues if they could not attend today. And that's all. Thank you very much for your time.
Thank you so much.